So members, today I'm going to see how do we solve differential equations. But please don't forget to subscribe to the channel. Now, solving differential equations will depend on their nature. Now, these are going to be specifically first order E's. I think now you know what we call the first order E. The first order E is when the highest derivative, the order of the highest derivative is 1. So now, one I don't see separable is. What do you mean by separable is? Now, if we have y dx equal to this, now can you separate them and you take the functions of y their side and the functions of x their side? That one, if you can do that, we call that separable, or that is called separable E. And after separating them, we like this. Now I take y this side, I take x this side, so that you see that this is the function of x with the command of x, function of y with the command of y. Then after we integrate, that's how we do it. Now I'm going to be having a simple example here. Solve the following. This one is the y is equal to this. Now this one is just separate. So that I can separate two, and I take y this side and I take x this side. Look here. X squared x are separated. After separating, you just integrate. If I integrate this, I get then plus a constant of integration. But we have the initial condition that when x is 0, y is 1. So now, that nicely becomes a half from here, and therefore I write this equation as then plus my arbitrary constant. Now this is what we call a particular solution. When I come to this, I do the same. Can I separate? This side can easily take this side and I take this side. So now this one I divide this side. Equaling to 9 against the other side over x minus 1. So that I can easily separate. So that's why I call it separability is. Then after separating, we integrate. We saw how to integrate this. We said the first division, we said that if I get 1, I need 2. So that one I get this reciprocal, then natural log of that function. That's how we integrate this. Then it's this one relationship, this I get 1. So this will be now natural log of x minus 1. Then plus a constant. Now this one is what we call the general solution because of this arbitrary constant. Now this one, can I separate? Let me see. First of all, this one, I can separate this one. 2 equaling to ex, then times e negative y using the indices. Now you see if I divide this side by this, you see that I'll be having now, I multiply by e y this side and by e y this side. When I multiply this will go to 0, so I'll be having now e y dy equaling to e x. So then I take this dx this side. So there I have separated. And from here I start I can easily integrate. I integrate this to get now plus c. But we have some conditions that when, because this is y and x, so this is x. That will mean that when x is 0, y is natural log of 3. So I put, so this is 3 equaling to 1 plus c, so that from here my c is 2. Writing this equation now plus a 2. This is what we call a particular solution because we don't have arbitrary constant. Here, even if you divide by this, then you take it up, you'll be having the same thing. Or you multiply here, it's up to you, anything you do. So, when I come down to this, can I separate? Let me see. I can take this, and now this is the y figure, so I can separate these two. So after separating, then we do integrate. So I integrate both sides. You see this will be now giving me, we saw this is done substitution, this is done inverse of y equaling to. Now you see this one is the same as, let's see, I cannot integrate this, but I can substitute it with something. You know that, or is my 2 cos squared theta is equal to 1 plus cos 2 theta. Where this is, I'm going to put this. And so now I'll be having now integral d theta, the whole over 2 cos squared theta, which will be, I take this half out, then integral 1 over cos squared is the same as x squared d theta. So here I have now tan inverse of y equal to 2. When I integrate x squared, we get tan theta, then plus the constant. So members, now in this one, you start this one, you ask yourself, can I factorize out this? Now you see here and here you can combine this. So if I combine this, you start 3y is common here. So if I move 3y here, and this will be now 2t. If I move 3y here, I take 3. What is common here is just a negative. If I remove it here, I have 2t plus 3. If you factorize out 2t plus 3, because it's common, here I have 3y minus 1. Now, this is equal to 0 dy dt. And from there, I separate. I bring this side and take this side. So we have now dy over 3y minus 1 equal to now 2t plus 3 dt. Then integrate both sides. When I integrate this, I literally this I get 1 over 3. The derivative of this is 3. Get this reciprocal. Then natural log of 3y minus 1 equal to now t squared plus 3t then plus a c. Now because we have initial conditions, please remember to them and simplify. I wish you the best.